शुना भाई चैनल में आपका स्वागत है। मैं हूं मोहान और आज हम एक नए वीडियो के साथ हाजिर हैं। इस वीडियो में हम आपको बताएंगे कि माउस, कीबोर्ड, प्रिंटर, लेजर प्रिंटर और कैमरा कैसे काम करते हैं।
I have always been curious about how the mouse wheel controls the page to slide up and down. Attention! This is a commonly used light-emitting mouse. It mainly has three key components: an infrared LED that emits light, a lens installed on the LED to collect light, and on the other side, two optical sensors that detect light, with an encoder mounted in the middle of the wheel. The encoder has 48 equidistant spokes that rotate as the wheel does. The appearance is somewhat reminiscent of the spokes of a bicycle wheel. So how do these three components work together to control the computer page? The roller carries an encoder, and when it rotates, the rotating spokes intermittently block the light emitted by the LED, and the light passing through the gaps is received by an optical sensor, which converts the optical signal into a pulse-wave electrical signal. When the wheel rotates once, the sensor will receive 48 instances of light and generate 48 light pulses. The pulse signal transmitted to the computer processor contains information including the angle and speed of the roller's rotation. The processor can then convert the angle and speed into the distance and speed at which the page should slide. However, there is another problem. The sliding direction of the page cannot yet be determined. This is why two optical sensors are installed. When the roller rotates, two adjacent optical sensors will detect the light one after the other. Based on the detected light, the different directions of the roller's rotation can be determined. The principle of sliding the mouse wheel up and down corresponding to the page is very simple. First, convert the mechanical rotation into an electrical pulse signal, and then convert it into the distance, speed, and direction of the page sliding. The inventor of the keyboard was a true genius. Externally, a keyboard comprises keys, a housing, and screws. Upon opening the keyboard, one can observe a rubber mat, each protrusion aligning with a key. Beneath this mat lies a circuit board interlaced with wires. Situated on the upper right side of the keyboard is the battery, adjacent to which is the microprocessor. Pressing a key creates a complete circuit loop on the board, signaling the processor to identify the pressed key. Releasing the key breaks the circuit. Despite there being only 11 contact points between the circuit board and the processor, with each point connected to multiple keys, the system can distinguish over 100 different keys. This is achieved by assigning each button a unique row and column number. For instance, when the Y key is pressed, corresponding to the second row and fourth column, the processor identifies it based on pre-established numbering rules. A mechanical keyboard operates similarly to a regular keyboard, but differs in that it has an individual mechanical switch under each key. Pressing a key causes two metal contacts to meet, forming a circuit and sending the signal to the processor. As a result, mechanical keyboards produce a louder click sound than their membrane counterparts and are more expensive. The inkjet printer is such a genius invention, but it's a pity that this device is still monopolized every day. If we enlarge the printed photo, we will see that the photo is made up of previous ink droplets. Not only that, the printer can print with only 4 kinds of ink. What is the magical principle behind this? The core lies in the nozzle. There are a large number of nozzles distributed on it, each thinner than a hair. The nozzle is designed to be wide at the top and narrow at the bottom, which creates negative pressure. Once printing starts, the heating resistor above will heat the temperature to 100 degrees in 0.000001 seconds, and the high temperature will cause the nearby ink to form bubbles. These act as pistons and push out the ink below. Due to the viscosity of the ejected ink, it will form a main droplet and a trailing droplet. They fall at a speed of 10 meters per second. The nozzle is 1 millimeter away from the paper, so it only takes 1/10,000th of a second to reach it, and it is absorbed by the paper in a very short time. The nozzle is connected to the printer through a soft tube. A non-inflatable motor drives the belt and pulley to move the nozzle, and a shaft stepper is added to move the paper. This is the basic structure of the printer. So how does one use 4 inks to print colorful photos? You might think of using a mix of red, green, and blue. Let's do a small experiment first. If you use a red and green flashlight to add and mix, you will get yellow. But if you mix red and green ink, you will get a very turbid yellow. In fact, this is the difference between additive color mixing and subtractive color mixing. For self-illuminating shades, mixing the two colors increases the brightness, but the ink itself does not emit light. We can see the ink because light hits the ink and then reflects into the human eye. This process will filter out part of the light. For a better understanding, let's magnify the ink droplets to a microscopic perspective. If the green molecules in the lower layer want to reflect green light, they must penetrate the green and red molecules in the upper layer. But this process will be blocked by the red molecules, producing black in this area. Similarly, the red molecules in the lower layer will also be blocked by the green molecules in the upper layer, and the resulting black color will cause a yellow change. To give another popular example, the gray hair we see with the naked eye is actually the result of a mixture of white and black hair. So obviously, the 3 primary colors of red, green, and blue cannot be used directly in the printer. The solution is easy. Just replace red, green, and blue with their complementary colors: cyan, magenta, and yellow. When the nozzle releases a drop of cyan ink and then quickly releases a drop of yellow ink, the two mix together to create an intoxicating green color. The diameter of the mixed droplet is only 0.05 millimeters, and a variety of colors can be obtained in this way. So what should you do if you want a lighter green? In fact, you can get a lighter green by increasing the spacing, which will make it appear darker, but the spacing is always limited. What if you want a darker green? This is when black ink comes in handy. Mixing black into green ink will result in dark green. The more black you mix in, the darker the green will be. So as long as you use the 4 colors of cyan, magenta, yellow, and black, you can print up to millions of colors. And a photo of A4 size can even have a motorcycle. We have to admire the wisdom of human beings. It's astounding how laser printers work. We all know that static electricity can attract things, but laser printers can actually control static electricity to adhere toner to the paper to form an image. Toner is made of resin, pigments, and electrical control agents, and has a diameter of only 0.05 millimeter. The core of the laser printer is the photosensitive drum, whose surface is full of negative charges. The photosensitive drum has a characteristic that it can remove static electricity after being illuminated. So when the laser shines on the photosensitive drum, the negative charges in the illuminated area become positive charges. Next, the developing roller transports the toner to the surface of the photosensitive drum. Since the toner itself has a negative charge, the positively charged areas of the photosensitive drum will be stained with toner, and the excess toner will be taken away by the sponge roller next to it. Now let's watch it in full. The sponge roller transports the toner to the developing roller. When the photosensitive drum is irradiated by the laser, the positively charged area will be stained with toner, and the positively charged area is the image we want to print. There is also a transfer roller below, which is responsible for pulling the toner off the photosensitive drum and attaching it to the paper. After being heated by the heating roller and pressed by the pressure roller, these toner particles are firmly adhered to the paper. On paper, the final image we need is formed, and all this process is completed in just 1 second. But what should I do if I want to print a color image? In fact, just repeat the above steps 4 times to absorb yellow, magenta, cyan, and black toner respectively. Just like ink, these 4 colors can be mixed to produce tens of thousands of colors, resulting in a colorful image. However, the cost of color printing is too high, so laser printers are more suitable for printing text and photos, and inkjet printers are better for color images. Why do others always take better pictures than you when you take pictures with a camera? It's because you don't understand how digital cameras work. Through this video, we learn how a digital camera acquires data from tens of millions of pixels and processes it to restore a painting within 1 second. We see the box on the table is green because light shines on it. This box absorbs light, and all colors except green, which is not absorbed, will be reflected, reaching our eyes. After processing by the brain, it tells you that this is a green box. Similarly, when reflected light reaches the camera, it first enters through the camera lens. There is a set of concave and convex lenses in the lens, which are used to enlarge and reduce the image. This process is called optical zoom. The hole in the middle of the lens is called the aperture. It consists of 5 to 9 aperture blades. By controlling the opening and closing size of the holes, it can increase or decrease the light entering the camera. The aperture is very important for photography, which will be explained in detail later. When the light passes through the lens and reaches the main mirror, the camera begins to work truly. The main mirror, set at an angle of 45 degrees, reflects all the light to the pentaprism, located directly above the main mirror. At this time, we can clearly see any object in the viewfinder. The clicking sound you hear when taking pictures comes from the rainproof box of the shutter. It is located behind the main mirror, and the image sensor is located behind the shutter. The shutter is closed during normal times. Its opening and closing are all controlled by being driven by an independent micromotor, and it can open and close in as little as 8 thousandths of a second. The function of the shutter is to control the exposure time of the camera. When we press the photo button, the main body will flip upward, blocking the viewfinder and releasing light toward the shutter. The shutter consists of 2 curtains, blades used to block light. When light reaches this point, the lower curtain leaves will fall. Light passes through the shutter and shines on the image sensor. When the shutter is open for a specified time, a second curtain falls from above to block the light. At this time, the shutter returns to its closed state. Next, it's time for the image sensor to start working. It can be said to be the heart of the camera. After we enlarge it, we can see many squares, which are all pixels. Suppose you have an 8-megapixel camera, then its image sensor will have 8 million pixels. Each of these pixels is a photodiode, which is similar to the working principle of a solar panel. Once light shines on it, all the pixels in it will begin to move and create an electric current. It is divided into 3 layers. The top one is the micro lens, and the middle one is the color filter. The first is the photodiode, which is what we call a pixel. Let's take a look at how individual pixels work. Let me explain it first. In fact, the camera only has 3 colors, red, green, and blue, but the combination of these 3 colors creates other colors. The first is the micro lens, which is responsible for focusing the light on the pixel. So when the light reaches the green device and passes through the micro lens, the green device will recognize these colors and combine them before passing them to the pixel diode. It is a light-sensing device that converts light into electrical current. In fact, this photodiode is a PN junction. When light shines on it, the electrons inside start 2 xanths of a second. The function of the shutter is to control the exposure time of the camera. When we press the photo button, the main body will flip upward, blocking the viewfinder and releasing light toward the move. The faster the electrons move, the greater the current intensity. Each pixel is equipped with a capacitor and amplifier. The capacitor stores the charge and prevents it from being lost. The amplifier amplifies the charge and sends it to the magic converter through a bus, and then the converter converts the current intensity information into 0 and 1 numbers, and then transfers it to the memory to form the photo we want. All the above operations are completed when you hear the camera click. Regarding the content of this aperture, we will have a video to explain it later.